Hello everyone, welcome to this video. In the previous videos, we have learned about iloc utility, and also we have seen that loc is a very useful utility when we are working with label-based data. So, a natural question that comes to my mind is, what is the difference between the two? Let's discuss this now. So first, we will create a sample data frame. Let me run this piece of code. This data frame contains detail about students with columns like gender, grade, marks, and their ID. Notice that the index is positional by default in this newly created data frame, 0, 1, 2, 3, and 4. Now, in order to understand the difference between loc and iloc, we are going to run a couple of experiments on this data frame. Let's do that. When I try to get the rows using 2 to 4 indexing using the loc utility, I get an output like this. So I have 3 rows in the output. So the first row has label 2, the next row has label 3, and the third row has label 4. If I use the same indexing in the iloc utility, I will get a slightly different output. Now I'm getting 2 rows in the output, and the first row has label 2, and the second row has label 3. Now notice that I'm seeing these things are labels and not index for now. Why is that? Well, we'll understand this better with another example. So coming to this example, first of all, we are sorting the entire data frame based on the marks column. So now this entire data frame is sorted in ascending order of the marks column. So 12, 14, 20, 21, and 22. Notice that the index is jumbled up. 2, 3, 4, 1, and 0. So it's kind of labels right now. It's not positional index. Now let's run the loc on the new data frame on positional index. So I'm seeing 2, 3, and 4 when I'm using loc utility. Now notice that loc just returns all the rows that fall between the rows having label index 2 and label index 4. That's what loc is essentially doing. Whatever things we have passed to loc, it has considered that these are label values, here 2 to 4, and it gives all the rows in between as the output. Now let's see what happens when we use the iloc utility with the same indexing. What is iloc doing? It gives me a row that has the label index 4 here, which is this row on the original data, and it gives me another row that has the label index 1, which is this one in the original data. So let's see what is the position of these rows in this data frame. So 0, 1, 2, 3, and 4. So this row has positional index 2, and this row has positional index 3, and this row has positional index 4. So what has happened here is iloc has splitted your data frame based on positional index. It doesn't matter what value is shown here, but what matters is what the original positional value of the rows in the data frame is. So when you say here iloc 2 to 4, it starts with positional index 2. This is the row at that index, gives you that as the output. Goes to the positional index 3. This is the row at that index and gives you that output. And ignores the last index, which is how iloc usually works. The way loc works is it doesn't take into account the positional index of the data frame. For it, all of these values are just label-based index. So it just starts with the row that has label 2. Then it finds the row that has label-based index 3 and just brings you all the rows in between. Now this is essentially the reason why the previous output of both utilities was not the same. And that is essentially what's happening here. iloc was always considering the position-based indexing, and the loc was always considering the label-based indexing. But we were not able to figure it out then, because when our data frame was newly created, the position-based index and the index that's shown here was matching. So here, in this case, it was 0, first, second, third, and fourth. Once we sorted the data frame, we just changed these values while the position index stayed the same. So this is how loc and iloc essentially differs. iloc always looks at positional index and loc always looks at label-based index. For it, these two numbers 2 and 4 are nothing but numeric labels. Let me show you another example to make it even more clear. So in this case, we were dealing with numerical label, and that's why we were facing slight confusion. Now instead of using numeric based labels, I'll set the index using a categorical column, which is ID. And in this case, what will happen if you use loc and iloc? Let's see. Now if you use iloc 2 to 4, it will still work because we have established this, that iloc only looks at positional index. So it will take the positional index at row number 2. So here 0, 1, 2, I105, and positional index 3, I102, and ignores the last one that you have given in. So therefore we have A105 and A102. Now try using loc here. It just gives you a big error. The reason for that is loc is looking for these labels in your index, but in your index you do not have numeric labels. You actually have categorical labels. So if you want to index things now using loc, you cannot give numbers. What you have to do is you have to give the categorical values that are labels. And if you run this here, you'll get the correct set of rows. So this is how label-based indexing and subsetting is done in pandas. And this is how iloc and loc differs. iloc only works with positional-based indexing and loc works with label-based indexing. Thank you for watching this video.